This is part 2 of the video lecture for Math 110 for Friday, April 24th. Today we're talking about the law of cosines. And the first part of the video lecture, we stated the law of cosines, we motivated why we would need the law of cosines, and we applied the law of cosines to a right triangle to show it reduces to the Pythagorean theorem. In the second part of this lecture, I'm going to do 2 example problems where we apply the law of cosines to solve a triangle. What if we have this triangle, and actually this is the triangle I presented to you guys in part 1 of the video lecture. What if we have this triangle? How do we solve for this? Well, as we talked about, we can't use the law of sines, which I showed why that was in the part 1. But we can use the law of cosines, which I've written right here. And the first step, again, is labeling the angles and sides of my triangle. I'm going to call this angle A, angle B, and angle C. And this means this is side A, this is side B, and this is side C. So in this triangle, what do we know? We know a side, we know another side, and we know an angle between those 2 sides. The name for this type of triangle is an SAS triangle. This is an SAS triangle because we know a side and an angle sandwiched between those 2 sides. For SAS triangles, we can't use the law of sines to solve them, initially at least. We have to use the law of cosines. So what I'm going to do here is use my law of cosines. I'm going to use this equation and start plugging in numbers here. And so a squared, I'm going to solve for a squared. A squared is equal to b squared, which is 18 squared, plus c squared, which is 30 squared, minus 2 times b, which is 18, times c, which is 30, times cosine of angle A. And we know angle A, it's 115 degrees. And now I would like to solve this equation for a squared. And so if we go through the steps of this, a squared is equal to 18 squared is 324, 30 squared is 900, and then we get 2 times 18 times 30 times the cosine of 115. And this comes out to negative 456.4. Okay, so we have a minus sign here, but then if we multiply all these together, this is also negative. So that's important to keep. It's important to remember there's a minus sign, but this quantity here is negative as well. So this is what we get. And now if we solve for a squared, we add all these things together. Be careful here because 2 minus signs make a plus sign. Okay, so this turns into a plus in this case. Whereas if this quantity was positive, we'd have to subtract it because this is negative and we have a negative sign. We get a positive quantity there. If we add these numbers together, we get 1680.4. That's a squared. And the final step here, don't forget about this, take the square root. So if we take the square root, a comes out to 41.0. Okay. And so now we know side A is 41.0, which makes sense to us. It looks like side A is the longest side of this triangle, and that's indeed what we find here. Now we still need to solve for angles B and C. How do we do that? Well, the way we do that is we then use the law of sines. So once we've used the law of cosines once, we can use the law of sines to solve for angles B and C. So to solve for angle B, I'm going to use the law of sines, which says sine of angle B divided by the side length B, which is 18, okay, equals, and then I'm going to use this angle pair here, side angle pair of A, to do this part. So now I can write sine of angle A. Well, angle A is 115, okay, and side length A we just found is equal to 41.0. And now I solve this for sine of B. Okay, so sine of B will be equal to 18. And I can do this by cross multiplying. I'll save you guys the algebra steps, but you can verify this. Sine of B equals 18 times sine of 115 divided by 41.0. And this comes out to, 0.398. Now this is the sine of B. To get B, we have to take the inverse sine to get angle B, because we're not interested in sine of B, but angle B. So angle B will equal the inverse sine of 0.398. And this comes out to 23.5 degrees. So this is now angle B. We found side A. The only angle remaining here is angle C. Now this is easy because we know the angles of a right triangle add to 180. So angle C will equal 180 minus angle A, which is 115, minus angle B, which is 23.5. And this comes out to 41.5 degrees. And so this is angle C. And now we've completely solved this SAS triangle. Again, we had 3 unknowns, and we solved for 3 more things. We know all the angles and all the sides of this triangle. Okay, I want to do another example problem. So let me erase this. I'm going to draw another triangle for you guys and see if we can solve this triangle. Okay, this triangle is here. This is example problem 2. Suppose we have a triangle that looks like this. Okay, and let's see, what we know here is this side is 22, this side is 15, and this side is 19. Okay. All right, this is what we know. Now this is an interesting triangle because we don't know any angles in this triangle, but we do know all the sides of this triangle. So this is called an SSS triangle because we know all the sides. Now we can't use the law of sines to solve this triangle either because the law of sines, you have to at least know one angle of a triangle to use the law of sines because the law of sines, any pair of the law of sines involves at least 2 angles. So because we have no angles and any version of the law of sines I use involves 2 angles, I have to know, therefore, at least I have to know one angle of a triangle. I can't use the law of sines. And if you guys want to, I'm not going to show you why that's true, but if you want to verify it, try using the law of sines in this triangle. I guarantee you, you will not be able to solve it. So here again, we have to use the law of cosines. What I'm going to do is label the sides of my triangle. I'll label this angle A, this is angle B, and this is angle C, and therefore this is side A, this is side C, and this is side B. And now I'm going to use the law of cosines to solve this triangle. So again, the law of cosines is a squared equals b squared plus c squared minus bc cosine of angle A. Or there's 2 other versions of that where we apply this to the other 2 sides, but this will be good enough for now. And I'm going to start plugging in numbers here. And so a squared is 19, so or a is 19, so I get 19 squared equals b squared, which is 15 squared, plus c squared, which is 22 squared, minus 2 times 15 times 22 times the cosine of angle A. Okay, now the good news here is I have one unknown here, angle A, and so I can solve this triangle. So let's start squaring things out. 19 squared is 361, 15 squared is 225, 22 squared is 484. And now if we multiply these numbers together, this comes out to 660. But we have this minus sign, so we get minus 660 times cosine of angle A. I want to isolate cosine of angle A. That's what I'm solving for here. So I'm going to start moving stuff around. And I'm going to subtract 484 and subtract 225 from both sides. So if I do that, I get 361 on the left-hand side minus 225 minus 484. Okay, and since I subtracted these from both sides, here these cancel out and those cancel out. And this leaves me with minus 660 cosine of angle A. So we're solving for cosine of angle A. And if you guys add these numbers up, these numbers right here add up to, what does this come out to? It comes out to minus 348. Hearing some sirens in the distance if you guys hear that. And now what I want to do is solve for cosine of angle A. So I divide both sides of this equation by minus 660. Okay, minus 660. Divide by both sides. These cancel out. And I get cosine of angle A equals minus 348 divided by minus 660, which comes out to 0.527. Okay, now the two minuses canceled out here, so it just gave me a positive. Now keep in mind that I don't want to solve for cosine of angle A, really I want to solve for angle A. So I'm going to take an inverse cosine of this number here, right? So if I have cosine of A equals a number, then angle A equals the inverse cosine of this number. And so angle A equals the inverse cosine of 0.527. And if you guys plug that in your calculator, you get 58.2 degrees. Okay, so this is angle A now. So now we solve for angle A, 58.2 degrees. Okay, we still need angles B and C. How do we get those? Well, what we can do now is use the law of sines to solve for angle B, for instance, or you could use it to solve for angle C. I'll use it to solve for B, and I get sine of B over side B, which is 15, equals, and here now, I now know a side angle pair right here, so I'm going to use that. So sine of angle A is 58.2 degrees divided by length of side A is 19. If we solve for sine of B, and again, you guys can check the arithmetic on this, sine of B equals 15 times sine of 58.2 divided by 19, okay? And this comes out to 0.671. Okay, but I don't want the sine of B, I want angle B. So then I take the inverse sine of this, just like we always do. Take the inverse sine of this number. Okay, and this comes out to, if you do that, you get 42.1 degrees. 42.1 degrees, that is angle B, okay? And that's nice to know. And all we need now is angle C. Well, this is easy because, again, the angles add up to 180. So to get angle C, C will equal 180 minus 58.2 minus 42.1. And if you plug this in your calculator, you get 79.7 degrees for angle C, which makes sense because angle C is the biggest angle here, and therefore it must be opposite the longest side. So that makes sense. Although it looks like, by the way, it looks like angle C is a little bigger than 79.7. Just keep in mind, these triangles aren't perfect. The way I draw them, the sides are not exactly proportionate. So you may notice the triangle doesn't quite look like the numbers I get, and that's just because I'm a human and I can't draw it perfectly. So now we've solved this SSS triangle, and that's great. We're almost done. I just want to point one more thing out to you guys. So far we've dealt with different types of triangles. If you guys are curious about this, we've dealt with these types of triangles, an AAS triangle, an ASA triangle, and an SAA triangle. Excuse me, SAA triangle, come on, David. And we've dealt with an SSA triangle. All of these triangles you can solve with the law of sines. And then today we learned about some new triangles. We learned about an SAS triangle and an SSS triangle. And these you can solve with the law of cosines. You might wonder, are there any other types of triangles? And by the way, this type just means we know an angle, and a side, or an angle and a side and an angle mean we know the side between two angles, and so on. There's a sixth type of triangle called an AAA triangle. And by the way, it's funny, SSS, no resemblance to Nazi Germany intended, no resemblance to AAA auto insurance intended here. AAA triangle, can we solve this triangle? Well, this triangle is non-solvable. And the reason is, if we know every angle of a triangle, the shape of that triangle is uniquely determined, but if we don't know any sides, we don't know how big it is. So an AAA triangle, we have no idea of the scale of it. You could have a tiny AAA triangle or a huge AAA triangle with exactly the same angles in both cases, but because we don't know any of the side lengths, we can't go any further, we don't know how big it is, and we really can't solve this type of triangle. Okay, I will see you guys on Friday.